Hello, how are you guys?
I'm great.
Good. How are you, Stefan? Hello. And Devansh is here.
Hi,
Hi, how are you?
yeah, I'm good. You might have been speaking before, I didn't hear you, sorry, and it was an audio issue.
That's okay. So, welcome to the meeting. So, we have a new person joining us here. Okay. Uh, Devansh, and he is from the other group that I run in DevoWorm. He's been attending those meetings. So he got excited. I mentioned something about Bradenburg vehicles in that meeting, and he got interested in this meeting. So, Devansh, can you introduce yourself and tell us a little bit about what you're interested in?
Hi, so I'm a third year undergraduate at NSIT Delhi, and I lead like the robotics club at my college, and we have been working with turtle boats and mobile robots in general. So they can be modeled by better work vehicles. So I just wanted to see what goes on over in this group. That's why I'm here.
Okay. So that sounds pretty good. So you have some experience with Bradenburg vehicles.
No, that's not how we think about it usually, but I did study it in practice in theory, but that isn't usually how we work practically with real robots.
Oh, okay.
But we do use like a lot of stimuli. We have a bunch of cameras, we have a bunch of radar sensors. They act as a stimuli, but we program the whole thing, and it is a little different than that when you like actually go and move them around.
Oh, good. Well, that's good. Well, hopefully we'll talk about some things that are interesting to you. And, just if you have any questions or if you want to present anything, let me know. Obviously not today, but like in the next week, few weeks or whatever. It would be, that's the way we usually run the meeting. So, Jesse might not join us today. He's not feeling well. He might come in. And then Z is going to be late. So, hopefully, let's see, where should we start? So I guess the first place we'll start, I wanted to talk about the abstract for the Twitter conference that I mentioned last week. So that deadline is actually February 21st. So they opened up the abstract portal since we met last, and they have the deadline of March 21st or February 21st for abstracts, and then March 20th for the conference. So the first thing I wanted to do is kind of talk a little bit about the abstract. Let me present my screen. Kind of hoping Z would be here, but we can wait, or I can tell him kind of the highlights when he comes in. So you can see my screen. All right. So the call for abstracts is here. So frequently asked questions. So this is for, I don't know if maybe Ankit wasn't here last week. I can't remember. Anyways, if you don't remember this, then here's the information. So what is OHBMX? This is what they call the conference. It has to do with the equinox. So it's a brain imaging conference, but they have other neuroscience type stuff there. It's an online event that happens on Twitter during the equinox. So it's like all day during the equinox. They have people in different time zones present these 5 to 6 minute presentations, or actually I think 15. And you just wait for people to read it. You put another tweet up, and then it's up on Twitter for the foreseeable future. And the great thing about that is people can retweet you. They can find your information about your project in a convenient place, and you get quite a bit of exposure from this. So there's a lot of neuroimaging at this conference. There's some computational modeling. There's some, other types of neuroscience. It's focused mainly on neuroimaging, though. There's a lot of that type of work. So, let's see. Okay, here it is. What does OHBMX stand for? It stands for Organization of Human Brain Mapping Equinox. So, that's what that stands for. And the organizers, 15-minute slots. So they're enforcing this series of no more than 6 tweets. So the things that we have to figure out for this conference are 2 things. 1, we have to figure out what the abstract is going to look like. And 2, we have to figure out what the structure of the presentation is going to look like. So the first deadline is the abstract. That will be on the 21st. And the abstract should be no more than 3,000 characters long and will be published in the online conference proceedings. So they have a conference proceedings this time. A participant follows the talks online and can comment and ask questions of the presenters and keynotes. So there will be people potentially asking questions during the session, but it's not something that's always required. What is the planned structure of each tweet? So they ask this question and you can go, I have the answer and how I did it last year. And I think I showed you that last meeting. But this is basic. These are the rules here. So the rules are organizers will allocate accepted proposals into a program for 15 minutes. Then each presentation will consist of no more than 6 tweets, which is, it's usually like a piece of text and then maybe an attachment. Tweets can contain pictures or even links to sources or papers, but the presentation should be understandable just by reading the tweets. So, the text, the little bit of text that you can put in a tweet, plus the image is what we need to constrain ourselves to. And we're allowed 6 of those. The audience can comment and ask questions for the presenter using the official hashtag. The main discussion should happen before the next presentation begins. But you can, they can ask questions offline too. Example, well, we already saw an example last time. Here's Jesse. Hi, Jesse. Okay, so that's basically the idea. So this is an example here. You have a tweet. They have number 1. This is the introduction. You might ask a simple question, and then put your hashtag here, and then you have a picture. So this is like a slide from a conventional talk, and then we do this 6 times, and we have to pick like the most representative things from the. I would just say from the paper that we can think of. But before we do that, we have to figure out what the abstract should look like. And this is the abstract I kind of came up with here in this file. Let me share this file. I think it's open to everyone. I'll put it in the chat. So this is the abstract, and this is based on the abstract from the paper. So I've trimmed it a little bit. I might follow up on a neuroethology theme. So developmental neuroethology in a computer. So this is just about neuroethology as a study of brain behavior in the context of the animal's natural environment. And then, of course, we're in a computer, so we have to modify that somewhat. We can observe naturalistic interactions using computer simulations. I don't have that sentence in here, but I'll put in something like, well, maybe here. Put in a, and then something like this. So we can make naturalistic observations of a model system. In this case, it's Bratenberg vehicles. But, you can think of it as kind of like a model organism or some other organism that you might observe in nature. And then in behavioral simulations, this naturalism can be approximated through interdependencies among brain, body, and environment. And so this is the kind of thing we're doing in Bratenberg vehicles. Then maybe this sentence, then we will use a type of Bratenberg vehicle called developmental Bratenberg vehicles to model the developmental aspects of an embodied artificial nervous system. And then you kind of go through some of the things that we're going to present. We'll present the 3 software projects, and then maybe a little bit about this first part. And then we'll, of course, mention the paper. And by the time we give this presentation, the paper should be out, but we don't have the exact citation now. So we'll put it as a citation here as in progress. So the abstract will have this sort of building anticipation to the paper, and then by the time the presentation comes, we can give the full citation and link to the paper. And that should be good. Then maybe we'll also this is something that might be a little bit too much, but we can at least touch on the use cases. So we talked about these cases in the paper, and Stefan and I talked about it more in depth. He did his presentation INCF on use cases. So we might have a single tweet on that, on the use cases. So that's the structure that I propose. Does anyone have any questions or comments about that? Ankit, I think you're muted. Okay. Yeah, TSP with vehicles. All right. I'll put that in my notes and then.
Hello.
Oh, hi.
So I was just telling that like the abstract that you have prepared, that has to be within 6 tweets, right?
The abstract has to be less than 3,000 characters, but the presentation has to be with 6 tweets. Yeah, so it's like 6 pieces of information.
Fine then. And I actually looked at one more conference of INCF accepting similar kind of abstract. If you have gone through it, I just sent you the link.
Oh yeah, the investigator. Yeah.
Yeah. So its deadline is day after tomorrow. So I don't know if we can make it.
Well, I submitted something for this This is for investigators. This is something I actually put a proposal in for. I'm not sure where I put that proposal. It might be in I think it's in the proposals folder here. I don't want to pull it up right now. Yeah, I did a proposal for this based on some themes in the it's more of an open science theme that I proposed to do, like basically this type of interaction, this type of collaboration. But yeah, I actually did send a proposal out for that, but that was more for investigators, like primary investigators. So, but yeah, thanks for the heads up on that. But yeah, so the tweets will be like 6 tweets. We'll have an intro tweet, and then maybe like the 3 software platforms. I'm just putting this down to get it straight in my head. And then maybe one on TSP vehicles, It's use cases. And then the last one would be like read more, which would be just like a pointer to the paper.
Mm-hmm.
And then solicit people's feedback so that they, get into it and they know that you're interested in their feedback on, like not immediate feedback, but that they can contact you. That's basically how you would do this. So, I mean, it's just basically, we have the stuff from the paper for each software platform. Well, we'd have to just basically decide on what would be represent, like, we'll need to have like a single image for each project, what would be most representative. And it sounds easy, but it's maybe not. Would we want a screenshot? Well, I want Stefan and Ankit to think about this, and Z as well when he hears this. But to think about, like, what is the most representative image you can think of from your platform? So, like, for Stefan, it might be a screenshot, but, maybe, it's a way we can make, like, a screenshot, and we can put an inset in it with, like, some of the readout. There are different ways you can do it with Ankit's. I like the screenshots that, if you just take a screenshot of his platform in operation, it's really eye-catching. But it's like, is there more we can kind of put in there?
I think it should be there in one of my presentation pages. So it has the screenshot is there, and like beside that there's some text explaining that what exactly is happening.
Okay. Could you use a GIF? Yeah. I think you could use a GIF. So yeah, we could have animations. Just as easily as static images. Okay. Yeah, Stefan says he would like a screenshot with diagnostic information. Yeah, that's what I was thinking too. And then, you just put it in an inset. Yeah, we don't want to put too much text in it, but like usually, if you're doing a figure, like the way they say for presentations, they say try to make it visual, but maybe add some text, but you don't want to like load it down with text. And I'm guilty of that a lot of the time. I'll put maybe too much text in a lot of slides, but like for something like this, it would be like maybe, limit yourself to 10 to 15, well, I would say words, but maybe, 50 characters total on the slide, just somewhere. Yeah. And so Ankit wants presentation slide, maybe a GIF, maybe like a screenshot of his.
I had something like that in my presentation, so I'll just look at it.
All right. And then Jesse, if you want to, I know this is a little weird, but if there's a GIF we can make or an image we can make of the vehicles, like kind of a theoretical view of what maybe we can just like mock up a vehicle, and sort of show how it's like, show something about its embodiment or how it might. Oh, there he is, Z. Okay. Hi, Z. So Jesse said yes. So yeah, it's like, maybe show like how the vehicle is embodied in its environment, and then like make some point about how that's, more naturalistic than say like just studying, just a regular simulation that, behavioral simulation doesn't have an environment, something like that. I mean, there are ways to get your point across visually. That's what we're trying to do here. So yeah, give that some thought. Then Z, so I've been talking about the abstract for the Twitter conference. And let's see, let me go over this real quick. Let me share my screen. So went over the abstract. It's in this link. I don't know if you have access to the link, but I'll post it again in the chat.
We don't have the access actually.
Oh.
I just requested.
Okay. Well, I can send. Yeah, it's coming up. I can send it again. And so this is the call, or actually this is something else. This is the abstract right here. So this is the way, this is taken from the paper, and it was modified a little bit. I'm using a neuroethology theme to put, to present this to people at this conference. That's what I'm suggesting. So this is the study of brain and behavior in the context of an animal's natural environment. Then in behavioral simulations, this naturalism can be approximated through the brain-body environment interactions. And then we get into this talk. So the way we would do the Z is we'd have we have 6 tweets total we can do in this presentation. We have the 3 platforms. Then we have like a slide, an introductory slide. Then we have like a slide on the use cases. And Stefan said, he wanted to do one on the TSP and vehicles. So it would just be like a summary of that. And then a concluding tweet, which would have information about the paper and then about like how to contact us to give us feedback, that sort of thing. So what I need from you, Z, is I need you to think about what kind of image could you make that would be most representative of your platform. So can you get it like a screenshot? Can you create like a screenshot of your environment, maybe with some diagnostic information in it? Something that really sort of gives a one slide demonstration of what is going on in your environment. Well, by then the paper will be live, so we'll be able to link to the paper directly and then direct them to read more about it. But, we want to have a good, succinct visual summary of the platform. So that's what we're looking for. And we'll kind of go through this again in another meeting, but I just wanted to give everyone a heads up to get them thinking about it. The deadline always comes faster than we can really, it seems like we say, well, it's a ways off. And then soon as you know it, it's here. So, let's see. I pulled something up accidentally here. I think this was the thing that Ankit was talking about here. So this was the INCF investigators presentation. So this is the one that you mentioned. I put in a proposal for this, and this would mention everyone here in the presentation. So I focused on, I submitted in this track, modern ways of doing and sharing science. And there are a lot of different categories, but I thought that was probably the one that had the strongest proposal for. So this was, I don't know if I can get to it from here. I didn't want to go, well, actually, maybe I can. Let's see if I can go to this one here. Proposals, proposals.
It was there.
And here.
Yeah.
And this is it right here. Okay. So this is the one I submitted for this. Developmental neurobiology meets informatics. So this is the one, it matches this like new ways of doing science track. This is actually a presentation that I've been wanting to develop for DevoWorm. And so in DevoWorm, we kind of have this structure that's a new sort of way of doing science, or at least very different from like the conventional physical lab. It's where you have a bunch of collaborators around the world, and they come together in virtual spaces, and they use data that they get from other sources, and they share data and expertise. And so, this proposal is to explain a little bit about this in the context of developmental neurobiology. So I'm combining what's going on in this group, and I'm combining what's going on in DevoWorm, and I'm kind of presenting that as a new way of doing science, or a different way of doing science, so that attendees will get some, a little bit of different perspective out of this and how to do science. So I mentioned, I think, different things that are involved in this. So one is hybrid research education. So the type of thing we're doing right now is kind of hybrid research education. We're learning things, and then we're also planning research and doing some research. So, talk a little bit about how that's not only been in here, but in DevoWorm. Also collaborative flexibility. So the vision for this is to have people from different areas of expertise, but also different, levels of expertise. So like people have been doing this for their entire lives. We have people, in their 60s and 70s who have collaborated, and we have people, grad students in their 20s and 30s, and then people in the middle of their careers who are also contributing. So we get people who have done a lot of things. Oh, thanks, Jesse. This is cool, he said. So, you get people who've done a lot of things. Maybe you're just starting out. Maybe you're somewhere in between. And they all bring their perspectives to this. And so, if you've not checked out what's going on in DevoWorm, I know Jesse and Devansh have checked this out. But, I gave a presentation a couple weeks ago on a recap of the project. Project's been going on for about 6 years. So, there are a lot of things that kind of happen and then go are put aside, and a lot of milestones that are met, and we just kind of blow by them. But in this presentation that I gave a couple weeks ago, we kind of revisited a lot of the milestones, and it was actually kind of impressive what's been done in the last 6 to 7 years. So I thought, well, maybe that's something that we can mention in this presentation. So actually, this is it. No, this is it. Okay, so this is the presentation that I'm proposing. So it draws from this group, and it draws from DevoWorm, and it demonstrates how this new kind of developmental neuroscience can proceed. And then mention a little bit about maybe some work on networks and connectomics, cellular systems, using biological data. I mean, this is just going to be like a smattering of different things that have been going on, but to reinforce that you can do science with very little overhead. And then another contribution is that there's a strong cross-disciplinary contribution to the talk. And so people who are attending this talk, they'll be learning about how you can do cross-disciplinary, interdisciplinary work using this approach as well. And so, again, it's going to be, I'm going to be presenting I'm going to mention a lot of people in this. So I'll probably be mentioning you guys in it. And then maybe if you want to contribute, I can mention you specifically. I probably just mention you just in terms of an example of what's going on. But that's not accepted yet, of course, but that's what I submitted. So, what else? So that's just for that INCF. That deadline was a couple days ago. So, and then this OHBMX abstract is due in about 12 days. It's due the 21st. So, and I'll give Ankit. I don't have access to the. I'll send you permissions to access it. I can't seem to do it right now, but after the meeting, I'll do that. And then you can edit it. And anyone else, I think you might have to ask for permission, but just send a request and I'll fill it after the meeting, and then you can edit it accordingly. And we'll edit it in the same way that we usually edit things. Just put in like a comment or suggest something, and we can take care of that. So there's Jesse. Yeah. Next business, I guess.
I'm like sick in bed.
Oh, okay, sorry. That's fine. Well, thanks for joining us. Yeah. The other thing I wanted to mention before we get on to the manuscript again, was to mention the. The FQXI essay. So we've had a couple of, Jesse, I think, made a couple commits to it this week. Or actually, I think he issued 2 pull requests. So, again, I'm sharing my screen.
Yeah, I wasn't quite sure. I made a comment about this and I didn't see if you replied yet, but I felt like if they're typos or whatever, I could just make a commit to it.
Oh, yeah.
But there were some like other things that were more intense, so I'm like, should this be a pull request or I don't know if that would, you know.
Yeah, I mean,
I don't know how this should be.
I think if it's something substantial, then make a pull request, because it's, you're going to have, like, if you issue a pull request, you can see the diff, and the diff is like what's been changed. And so you can go back in GitHub and like look at the diffs. You have to look at the history of the file. And if you go into the history, that you can see the different versions. And so usually the pull request will generate a diff, and you can see. So in case something happens, and this is just a general thing about editing things in GitHub. If something happens and you're not quite sure what the change was, you can just go back to that version and then go look at the diff and see. So yeah, definitely make pull requests for like big changes, but for typos you can just make like you can just submit it. But this is again the essay. So now we have an introduction, and I need to get back to this, but I haven't had time. Then what makes a problem hard to represent? And there are a couple of points: difficult to quantify, difficult to symbolize, unphysical problems, no physical analog, and then questions that result from these issues. And then there are like some kind of open questions which we'll need to flesh out a little bit more. And then is a paradigm for measurement and computation the answer? And so our new paradigm, it should be, but I'm going to fix that later. But these are the 4 potential approaches. And then those are just things that I've kind of put in here. If you can think of new ones that we should add, you can put them in. If you think that these are, need to be combined in some way, you can leave a comment. And again, the comment is where you indent it with like the right arrow. Yeah, the right arrow hash about 5 times. You'll see if you go into the edit mode of GitHub, you'll see that, it's like how you put in this little comment. But yeah, these are the 4 approaches. And these are just kind of like methods that you might use that might be something that we don't think about usually in terms of characterizing systems. But, and then what Jesse, he added a reference here, Julian Jaynes the origin of consciousness and a breakdown of the bicameral mind. And so that was added up here somewhere. Yeah, up here in the difficult to symbolize section. So, yeah.
I think I might maybe move that to like the top of this as a difficult to symbolize section, but maybe more like it could potentially be a way of explaining all the other subpoints. So I'm kind of figuring out how to fit that in, but I think it's a very interesting point because it's sort of, the quote itself is something like, theory is a metaphor between data and a model, and it's sort of like the ways and means of making that metaphor are kind of the points below or related to that. So it's sort of like explaining the mechanics of the challenges, if you will.
Yeah.
But if you think you're better under one of the subpoints, you can move it to whichever one fits, if that's...
Oh, I think that's probably good to have, have it in difficult to symbolize. I think, because it's like, symbolize, I guess, is pretty broad here. Let's see if I have, what is this? Difficult to quantify. I don't really have difficult to represent, which is maybe what would be like the optimal heading, but I don't want to. Difficult. Maybe that heading should be different. Difficult to symbolize and
symbolize and represent.
Yeah.
Okay, maybe. I'll play around more with it too. It was just something that I saw elsewhere, and oh, this is a really interesting quote, and kind of fits with. The quote itself isn't saying difficulty, but I think it's an allusion to where difficulty can come up in the relationship between model data and theory. So.
Yeah. Yeah, I mean, there's probably a lot. They're probably. Like I said, I'm gonna have to turn back to this soon, but I've had a lot of other things going on. But the deadline for this is in mid-March, so it's not imminent. So, there are a lot of things that can be cited. I've just kind of got some open citations here at the end, as you can see. So there are a lot of things in here too that maybe need a citation. And maybe need to be phrased a little bit differently. So just kind of this is the way I kind of write the outline, and then you fill in the outline, and then you put in things that you kind of stream of consciousness, then you have to work those things out. So it's not, none of this is really set in stone, but trying to get some of these things cited and clarified, that's going to be a bit of an issue. Just kind of you want to make sure when you do a outline and you fill it in that you can keep track of what your thoughts were, because sometimes people put down things as stream of consciousness and not cite them, and then they come back later and they said, where did I find that citation? So it's just a general point in terms of writing is that maybe keeping the citations with the thought is a good strategy there, because otherwise you can really kind of waste a lot of time trying to find them, even if you have a bibliography. So we're moving on this, and of course Ankit was interested as well in participating, and so I welcome his inputs. Again, we have several more weeks for this. It's in the middle of March, I think, is the deadline, so we have some time. And again, just feel free to go through and put in comments. And then if you find something that's really interesting, you can propose a citation, or maybe a point that we missed. Maybe point us to different things that you can think of that might be suitable. And so that's a good way to contribute. And then, we'll keep revisiting this over subsequent meetings until the deadline. So, okay, so now let's move on to the paper. We have 20 minutes left in the meeting. So for Devansh's benefit, this is a paper that the rest of us have been working on in the meeting, and this was an outcome of last summer's Google Summer of Code work session. So this is actually how this group formed, and this was Ankit, Jesse, Ziyi, and Stefan were all applicants to Summer of Code last year, and they all did very good proposals, but we could only fund one. And so what we all worked on, we actually Ankit, Z, and Stefan all worked on platforms for Bradenburg vehicles, and they took different approaches. And Jesse has worked on an approach, but he didn't implement it last summer. But he's been working on the paper as well, and so we've all kind of pooled our resources into this paper. And so this is about 10,000 words now. It's about 9,200 or something like that. But it's almost ready to go. It's almost ready to be put out as a preprint. So in the next couple weeks, we plan to do that. So yeah, so Devansh is going to get a preview of it. But so again, we have the title, and I think it's probably pretty solid. But again, if you have tweaks, you can propose them. The abstract here, which is a version of the abstract we're going to submit for the Twitter conference, a bit longer. We've had some comments on that, and I think it's in pretty good shape. We might want to go over that one more time. The introduction, again, motivation, suitability for BVs and modeling development, neurodevelopment, development and connectionism, and then embodied cognition. I'm sorry. So this is where we start with, so Jesse and I have been working on this week, in the past week, and we're kind of in the middle of getting it organized. So I kind of went through this, I think, Tuesday or Wednesday, and I was working on some of the, like, organizing it. Jesse had put in some things, and then I think he commented back on some of this. So let's walk through this. So embodied cognition, I put in a couple of citations here, which is kind of a variety of different approaches. And again, this isn't exhaustive, but I just wanted to put in a couple examples. And these are actually, I think one is a philosophical reference, one is like a dynamical systems reference, and one is just kind of like a general reference. So I kind of tried to span the subfield there. And then we talk about emerging approach that draws upon psychology, biology, cognitive science, robotics, and complex systems. And then this is where Jesse proposed talking about Anthony Chermolo, who's a radical embodied cognition person, which is perfectly fine because we want to point to this version of embodiment that describes cognition in terms of agent-environment dynamics, which can be understood through the application of dynamical approaches. So when they say radical embodied cognition, I guess they mean that there's really no representation needed. I mean, that was my understanding, and so that's kind of good to bring up here because we were talking about the level of representation and Bradenburg vehicles, although they have like formally a representation of nodes and connections in their nervous system, they don't really have a representation per se. They don't have a representation, say, of things that they encounter in the environment. So we know from some of our projects that, if you go out in the world and the agent encounters like a light source or a scent or some object, it doesn't have a model of that in its brain. It just knows how to interact with it, knows like some basic properties. So it doesn't really have a representation per se. And then, we kind of get into this about traditional views of cognition propose a mind is not only a logical computation engine, but operates independently of the physical world. That seems a little bit rough. We might work on that a bit to smooth that out. I'll read over it again later to see, but this is something I put in anyways. So, furthermore, representations that can perform symbol manipulation are essential component of these computations. So this is the point that I think that Jesse brought up originally. That was where the mind is not only a logical, it's sort of the idea of brain and mind, and like the mind is like a logical device versus like something more. And so we might revise that a bit. Then embodied cognition challenges the notion that sensory inputs and motor outputs are peripheral or auxiliary elements of cognitive processes. Okay, I think that's maybe not. This may be, I would say probably the sensory world and action. Because it's like, I think people in cognition they think of things in terms of input-output systems. But I think the thing here is that a lot of traditional cognition doesn't consider is that the senses exist in a world of their own. Like, if you're moving around the world, those things exist independently of your brain, and then you perform action in that world, and there's a feedback. Most traditional cognitive science is more like the brain is an I/O device, like a computer. I put a disk into the computer, I get an output out of the computer, but the computer itself doesn't really model the world around it necessarily. So then there's this part here. So I mean, we're going through this section. I put in a couple additions, but I think another thing to pay attention to is that we have need for a couple of citations in here, and this is not just for Jesse, but for anyone who can think of good citations to put in here. So we have a couple here that I haven't numbered yet, and we have maybe some more citations that can be put in here. Then developmental BVs give us a unique opportunity. So the original conception of vehicles was as an embodied and representation-free model of simple cognitive behaviors. And so then we kind of get into how that differs in our approach. And then, again, this is unfinished here, but this is Jesse's note on talking a little bit more about the levels of representation, which might be good here, just very briefly, of course, because we don't really get a lot into like high levels of representation, but we might actually do here is kind of motivate what we're going to do later. Maybe with some specific examples from our models. I don't know if that replicates what we did later on here, but I don't think so. We can write it so that it doesn't. So, I'll think about that and put in some notes about that. Maybe later this weekend. But Jesse, you can put in any notes you want. Then generalized models of regulation. This section. Okay, again, yeah, we can expand it, but I think we could probably keep this brief. I'm almost thinking that EGRT and cybernetics might be a little bit too much here, but we can just kind of, we can add maybe another sentence of summary, but I really want to get into the methods here. The methods are...
I was going to say, I think that's right. If there's anything, it would be like one sentence referencing, because like EGRT, the aggregate regulator theorem, is like basically super representational. It's saying you have to like recreate the whole, you have to represent the system with a model in the system, and just kind of having that as like a sentence maybe juxtaposing that. I don't know if it's mentioned. I don't think it's mentioned in what we have there right now, but I feel like if there's anything to add, it will just sort of add that sort of contrasting, like very heavy representational focus as something to like point to as a like counterpoint, and then saying maybe how tying it's kind of there, but tying it into like we have these heavy learning, we have these other ways of kind of developing regulation as the actors move through the environment based on those methods of learning. And like that, I feel like that would be, if there's any more to add, that would probably be it.
Okay, that sounds good.
I should make a comment about that.
All right.
Okay, that's all though. We wanted to method and stuff.
Yeah, so then we're into the methods, and again we have the Broadgen brain methods with the code. We have the equations that look pretty good. I think Z put in a couple of comments on that. I accepted them. They were just modifications to his equations or the description. So, but you still have a chance to like make comments on these. On the methods and especially the equations, so feel free to if you want to. Yeah, here's Jesse's section here where he put in a couple of comments that I accepted. Actually, this somehow didn't make it. This should be subscript. There we go. In space, okay. And then that, and that looks good. And then, so that's Z's section, and then this is methods for solar intelligence using BVs. And again, here Ankit made a couple of suggestions for changes. I accepted those. It looks pretty good overall. At some point, I'm going to sit down and go through this thing from top to bottom and just like, read it to make sure it's perfect. And then I suggest you do the same thing. If you're, just kind of read it as you were reading something that someone else wrote. I know that's hard, but like go through and just quickly skim through it. Don't invest yourself in the oh yeah, I remember what that is, and just kind of like see if it makes sense. And if things don't make sense, you can put in a comment. But it's always good because when you focus on specific sections, sometimes you don't, you get kind of fixated on it and you think, oh, that makes sense. And then, so this one, it induces to two different, or actually it should be, maybe induces two, and then resulting. But, it's just like little, I think we're at the point where it's like little corrections are probably what we'll find. And that's fine. Just, it's like the proofing, almost like the proofing stage. So you always find things you never, in a paper this size, you always find things you didn't notice before. So then we have Ankit's section, and it's there. Then the results, computational model for developmental neuroscience. Again, this sets up the software instantiations, which are these three approaches, the Broadgen brain approach. Here are the screenshots. Then we go into agent nervous system. Then we go into Z's section, modeling neuroplasticity using multisensory inputs. We still have the figure from Broadgen brain, but that's, And then the environment, olfactory system. So here are the screenshots. So this is a nice screenshot. And I worry a little bit that it's maybe too compact. It might split this up just for viewing, like take this section and put it underneath, which wouldn't be a true screenshot, but it allows people to see a little bit more. Things like that. I mean, it's an option. So, I want people to be able to see what you're doing, and like kind of get be able to read some of the detail on it. So this is the odor space, the Lee Hopefield model diagram, and then bidirectional associative memory. Then we have that diagram, then we have the descriptions. Then this is Ankit's section on BD collectives. So I think all the references to deep learning in this part are taken out as you requested, Ankit. We have a screenshot here. We have another screenshot here. And we have our description in subscripts here. That seems to be okay. Then we have the table, which describes the collective BV behaviors, and so these are the vehicles from the book: 1A, 1B, 2A, 2B, and then the associating emotions and the connectivity. And so that's something that is in this table, but I guess that's a good place for it. I was thinking maybe that should have been up in the methods, but maybe there's more to say about that. I don't know. I got to think about that.
When we are talking about results, I think it suits it better here.
Yeah. All right, and then so maybe in the discussion too is a good place to put a discussion of this table, because it's actually useful for people who aren't familiar with Brainberg vehicles, to get them thinking about how these different paradigms fit into sort of the program that Brainberg sort of proposed, which was to have these artificial nervous systems in different configurations. So that might be something too to think about. Then the discussion, we have the discussion, which is just kind of a review of the paper, feedback and regulation and emergence. So this was something that I moved from the intro, and this might be a little bit of repetition from the first part. So we might actually condense this into something that's just part of this summary. So I'll think about that. I don't want to get rid of these references or anything, but we might just kind of give this as a brief comment instead of sections. Then we get into use cases. So now these are the use cases, which are practical ways to apply these platforms. So we have the hinge, the TSP, optimized spatial cognition, actually NSP, HBTSP. I don't know how they got there. Okay. And then cumulative classification, which is this is where, we might kind of point towards the machine learning applications of Ankit's platform. So this is just kind of, a proposal for how this might look in the future. So I think I mentioned deep learning, but just kind of tying it to what's already in the literature. So, so that, and again, Ankit, if you think that that's right or wrong, let me know. Because we want to make sure that it isn't too ridiculous sounding, but if there's something to add there, make it make sense, then let me know. Limitations and future issues, and of course that's the end of the paper, because you just talk about how you might improve upon it or whatever. And so then our references are in pretty good shape. Again, there are references that are being added now. Those are just at the end here. So they're unnumbered, and I just put them in alphabetical order. So this is after 58. So this is, Jesse should pay attention to this. This is where if you want to put any additional references, put them here. Okay, and then I'll number them later. And then put them the author and the year in the text so that we can match them up. And then I'll renumber these. We're at 50. Well, we're at about 64 references now, maybe 65. So we maybe could use a couple more. And I think 70 is good for a paper of size. And I think that'll be good. And then I think we'll be in good shape. So that's good. All right, are there any other comments or questions on anything we talked about at the meeting?
No, I think I went through the paper. Like you said, we need to go from top to bottom without fixating on some parts. So I would go again, but I went through the entire paper once a while ago, and then seemed like things making sense at different places.
Yeah, I think that's a good way. And then if everyone does that, I think we'll have a pretty good. I think it'll look pretty good, It won't look because sometimes you miss things. Again, like I said, that size of paper, you miss things, even with that many eyes on it. So it's always good to go over it once before you put it out there. So yeah, Z or Stefan, do you have anything else to mention, to add?
Yeah, I just keep in mind my section and working on it further, maybe revising the equations.
Okay.
But this week I will use to prepare for my exam, which is on Thursday, and afterwards I will be more flexible to do this.
Okay. Yeah. So you'll be after this week, you'll be able to do it. Okay, that's fine.
Exactly. Yeah.
Yeah. Thank you. Well, good luck on your exams.
Yeah. Thank you.
Yeah.
Yes. Good luck.
Z, did you have anything to add? I revisited the results part, and I think some paragraphs should be put in the methods section. Okay. Can you highlight them and put if you put a text, you put a comment over that part and put in methods, that would work. Okay. Good. And then I can move them. And then I just don't want too many people moving too many things around because it's you lose things that way. So so that'd be fine. And then so before we go, I wanted to ask Devansh if he has anything to add or if he thinks any. This was an interesting meeting.
Yes, I was going through the repositories of last summer, so I've seen Ankit's repository and Stephen, so I'm just seeing what has been done. So yeah, paper was definitely impressive. It's the first time I'm seeing such a huge paper, also. I'll go over the rest of the material until the next meeting, and I'll see if I have any questions.
Okay, yeah, thanks. Okay, I look forward to it. So thanks for attending, and we'll be meeting next week at the same time. If you have anything to present or talk about, please bring it to the meeting, and otherwise have a good week. All right, talk to you guys later. Bye.
Have a good week, everybody.
Yep.
Till then.